So today we are going to talk about some other method to reduce the non-exact differential equation into an exact differential equation form. So if m in every differential equation can be written in terms of m dx and n dy term. So if m is in the form like y f1 xy and n is the form of x f2 xy, then we can use the integrating factor as 1 by mx minus ny, and that integrating factor when multiplied to the equation which is non-exact, then it reduces into an exact differential equation, and then we integrate it and solve it like in previous class we discussed. So let us take an example of this type of differential equation and then solve it. Okay, so let's take an example. So we have y into 1 plus xy dx plus x 1 minus xy dy equals to 0. So here you can see that this is our m part and this is our n part. So if we differentiate it, del m by del y, then it becomes 1 plus xy, then plus y into x, and then del n by del x is equals to 1 minus xy, and then x into y. So you can see that both this term del m by del y and del n by del x are not equal to each other, so it is not an exact differential equation. Sorry, here this is minus. So here it is not in an exact differential equation form, but we can convert it into a exact differential form by from this method. Here y into some function of x and y, and here x into some function of x and y dy. So the integrating factor must be equals to 1 by mx minus ny. So 1 by m into x means xy 1 plus xy minus here also xy 1 minus xy. So this equals to 1 by xy plus x square y square minus xy plus x square y square. So this equals to 1 by 2 x square y square. Now multiply this integrating factor with this equation and integrate it. If we multiply, then it becomes 1 by 2 x square y square y 1 plus xy dx integration plus x by 2 x square y square 1 minus xy dy integration equals to constant, some constant. Then you can see that here 1 y term is cancelled out here, and here also 1 x term is cancelled out. Then this equation becomes 1 by 2 x square y dx plus here xy cancel out, then it becomes 1 by 2x dx half of, and plus 1 by 2 xy square dy minus 1 by 2y dy integration equals to some constant. If we give the half 1 by 2 term common out and give to other side, then it becomes 2c here, and now we integrate both side, and if we integrate, then we can see that it becomes 1 by y, and this becomes minus 1 by x, okay, and plus ln x and this term becomes here it contains one x term, so the integration becomes 0, as we already talked it in previous class, that all the n term which contains x, the integration becomes 0 in this type of exact differential equation form. So this equals to 0, and here minus ln y equals to 2c, or we can say that it is 2c, or we can take it as c dash. Okay, so now this equation becomes, if we further simplify it, it becomes 1 by minus 1 by xy plus ln x by y, and equals to c dash. Okay, so this is the solution of that equation, which is already non-exact, but it must be in this special format, so that we can use the use this formula. Okay, so now let us take another example. If the equation differential equation is in a homogeneous differential equation is homogeneous. We already talk about homogeneous, where the upper side function dy by dx equals to some dy by dx equals to fxy by phi xy, where fxy and phi xy contains same degree or the power of each term of fxy and phi xy must be same to make it a homogeneous equation. So now let us take an example. If the differential equation is a homogeneous form, then the integrating factor equals to 1 by mx plus ny. Okay, so if the equation is differential equation, homogeneous differential equation, we can solve it by homogeneous differential equation method, but that method is a little bit lengthy. But if we convert it into a exact differential equation, then this method is very much simple, and it is less lengthy, and you can get the exact result within 1 to 2 minutes. Okay, so let's take an example, and let's take an example. So here you can see that this is a homogeneous differential equation, as the upper side have power 3 and lower side have all terms have power 3. So this is a homogeneous differential equation, but now we solve it by exact differential equation form. So if we multiply it like this, x cube y cube minus xy square ty. So here this is our m part and this is our n part, and if we check del m by del y, and it becomes 3y square, and del n by del x equals to minus y square. So here del m by del y not equals to del n by del x, so this is not in an exact differential equation form. So now if we have to convert it, so if we multiply integrating factor as 1 by mx plus ny, and it becomes 1 by x into x cube plus y cube plus minus xy square into y. So this equals to 1 by x fourth plus xy cube minus xy cube. So this is equals to 1 by x fourth. So now multiply 1 by x fourth in this equation and convert it into a exact differential equation form, then it becomes 1 by x plus y cube by x fourth dx minus x y square by x fourth dy. So here you can see that here if we cancel out 1x, then there is x cube is there, and due to this x cube, here here n terms contains x, means the integration becomes 0 of this part, and only this part is survive. So here it becomes ln x y cube by 3x cube equals to c. So this is our solution. So you can see that we can easily convert it into a exact differential equation form and then we solve it. So this is all about exact differential equation, and next we will talk about higher order differential equation.